The morning of June 27, 1944, smelled like cordite and seawater. Commander John Patrick Dowd, standing on the debris-strewn quay of the Gare Maritime, could feel the concussive residue of the last demolition charges still vibrating faintly through the soles of his boots, as though the ground itself had not yet decided whether it was solid. Around him, the harbour of Cherbourg was a still life in wreckage. Cranes lay on their sides like dead animals. The entrance to the wet basin was blocked by the sunken hull of a French merchant vessel, deliberately scuttled at a precise angle that suggested someone had spent considerable time calculating exactly how much damage a single ship, placed just so, could inflict. Reinforced concrete, tons of it, had been dropped into the basin approaches. Gate mechanisms had been destroyed not by explosives alone, but by cutting torches, applied methodically to the internal components. The kind of destruction that takes patience and specialized knowledge. Dowd had seen bombed ports. He had seen ports damaged by accident, by weather, by the ordinary violence of war. This was different. This was a port that had been studied, understood, and then unmade by people who knew precisely what they were doing. The German garrison had surrendered the previous day. They had held out longer than anyone expected, longer than made obvious military sense, and the reason was now apparent from the state of the waterfront. Every day of resistance had been another day of demolition work. The timeline of destruction was methodical. 3 weeks of systematic engineering, working backward from the most critical systems to the secondary ones, ensuring that even partial repairs would face compounding obstacles. Blocked entrances meant nothing if the quay walls were intact. Destroyed quay walls meant nothing if the cranes still functioned. So the quay walls had been damaged, and the cranes had been destroyed, and the basins had been blocked, and the electrical systems had been cut, at points chosen to make simple splicing useless. It was a complete theory of port denial, executed with professional thoroughness. What Dowd was looking at, the United States Navy had officially assessed as requiring a minimum of 9 months to restore to useful operational capacity. Some estimates ran to a year. The Allied supply situation, already strained after 3 weeks of fighting across the Cotentin Peninsula, could not wait 9 months. The breakout was coming. The armies would need fuel, ammunition, food, and equipment in quantities that dwarfed anything the Normandy beaches could handle. Cherbourg had to work. The question that no one had yet answered, the question that the German engineers who built those demolition plans had assumed would never require an answer, was a very simple one. How long would it actually take? Part 1. The Science of Killing a Port. To understand what the Germans built at Cherbourg and what they destroyed, you first have to understand what Cherbourg was. Not strategically, physically. The port of Cherbourg sits at the northern tip of the Cotentin Peninsula, facing the English Channel. It is not a natural harbour in any useful sense. The roadstead, the outer anchorage, is exposed and treacherous, and for centuries the peninsula's geography made it a hazard more than an asset. What made Cherbourg into one of the finest deep-water ports in northern Europe was not nature, it was engineering. French imperial engineering, begun under Napoleon Bonaparte and continued for 80 years afterward. The Great Breakwater, the Digue Centrale, stretches nearly 4 kilometers across the harbour mouth. It took 60 years to build. Behind it, the inner harbour complex includes a wet basin, a tidal basin, a dry dock capable of handling the largest ocean liners afloat, and a series of quays with a combined berthing length of approximately 3,000 metres. The depth at the main quay faces runs to between 9 and 12 metres at low water. That matters. That is the number that makes Cherbourg irreplaceable for supplying an army. You can land cargo over beaches, you can land small ships, but to land the truly heavy industrial material of modern war, locomotives, bulldozers, tanks, artillery, fuel in bulk, you need deep water quays. And in the summer of 1944, with the Allied armies about to break out across France, those quays were the difference between a sustained offensive and a supply crisis. The Germans understood this perfectly. They had been studying Cherbourg since June of 1940, when France fell and the Wehrmacht moved in. For 4 years, German military engineers, specifically the Kriegsmarine's harbour engineering staff, had access to every blueprint, every survey, every maintenance record the French Port Authority had accumulated. They knew the load ratings of every crane. They knew the depth of every basin. They knew where the electrical conduits ran, where the fuel lines were buried, where the structural weak points in the quay walls lay. When Rommel and von Rundstedt began planning the defense of the Atlantic Wall in late 1943, the question of what to do with Cherbourg if the Allies actually took it was discussed at length. The conclusion was straightforward: deny it to them for as long as possible. Not by defending it indefinitely, that was always a fantasy, but by destroying it so thoroughly that it could not function as a supply base for months. Long enough, the German planners calculated, to make the Allied logistical position untenable. The man most directly responsible for the demolition plan was Konteradmiral Walter Hennicke, 51 years old, career naval officer. He had commanded naval forces in the English Channel and was the senior German naval authority in Cherbourg when the siege began in mid-June of 1944. Hennicke was not a fanatic. He was a professional, and his demolition work reflected that. The plan he oversaw was thorough, systematic, and executed with a precision that impressed even Allied engineers after the fact. The demolition began on June 19, 1944, as American forces under General J. Lawton Collins tightened their grip on the Cotentin Peninsula, cutting off the German garrison. From that date until June 26, when the last organized German resistance in the port area collapsed, Hennicke's engineers worked continuously. What they accomplished in those roughly 7 days, some accounts suggest the most intensive demolition work was concentrated in the final 3 to 4 days, was extraordinary. Stop and think about what that actually means. 7 days, to destroy what had taken 80 years to build. The cranes came first. There were 7 large cargo cranes along the main quay faces. The Germans did not simply damage them. They cut the legs with shaped charges and toppled them into the harbour basin, where they would lie across the quay faces and the shallow water, blocking both berthing and dredging operations simultaneously. Each crane lying in the water was an obstacle that would have to be cut apart and removed before the quay could function. Each one represented weeks of salvage work. The quay walls themselves were attacked at their foundations. Explosive charges placed in the caissons, the hollow concrete chambers that formed the base of modern quay construction, were detonated to collapse sections of the face inward. 14 major breaches in the main quay complex. Several of them involved the collapse of 30 to 40 meters of quay face, creating rubble mounds that sloped from the quay surface down into the harbour bottom. To berth a ship against such a section, you would first have to clear the rubble. To clear the rubble, you would first have to dredge. To dredge, you would need equipment. The Germans had made sure the equipment wasn't there. The inner basin, the wet basin with its lock gates, was a particular focus. The lock gates, massive steel structures that controlled water levels and allowed ships to float in at high tide and remain afloat at low tide, were destroyed. Without them, the inner basin was tidal, meaning ships could only enter and exit during the roughly 2-hour window around high water and would sit on the mud at low tide. The Germans also sank vessels in the lock approaches, compounding the problem. The dry dock, the Forme de Redoube, was flooded and then blocked with a scuttled floating dry dock that had been deliberately sunk across the entrance. Clearing it would require both salvage vessels and divers, working in water that the demolition had made opaque with silt and debris. In the outer harbour, the Germans sank approximately 40 vessels. Not randomly. The positions were chosen to create a minefield of wrecks that would force any ship attempting to enter to navigate a narrow channel, slowing traffic to a trickle even if the quays themselves were operational. Some of the vessels were sunk in the harbour entrance itself. At least 3 were sunk directly against the quay faces, their hulls resting against the already damaged concrete, adding their mass to the obstruction problem. The electrical system, cranes, lighting, pumping stations, was destroyed at the generator level, not at the cable level. The Germans understood that cables can be rerouted and spliced. Generators are harder to replace. The freshwater system, essential for any port operation, was contaminated, and then the main pumping infrastructure was wrecked. And the mines. The Germans seeded the harbour basin, the approaches, and the key areas with a variety of mines, including pressure mines, devices that detonated in response to the pressure wave of a passing ship's hull, rather than contact, which were among the most difficult to sweep because they could not be triggered by conventional minesweeping techniques. Pressure mines require either waiting for them to exhaust their counters, some were set to fire only after a certain number of pressure pulses, or accepting losses. When Henniker was captured on June 26, Adolf Hitler personally awarded him the Knight's Cross by radio, citing the thoroughness of the demolition. That is not a detail for atmosphere. That is a precise signal of how the German High Command assessed the work. It was considered a success, a victory within a defeat. The Allies had the city, they did not have the port. And the port was what they needed. Henniker himself, in statements made after his capture and in post-war interviews, expressed confidence that the damage would take a minimum of 90 days to repair to any useful level of function. Some German planning documents captured later suggested estimates of 180 days, 6 months, before the port could handle significant tonnage. Hold that number, 180 days. Part 2. The system the Germans didn't know existed. Here is the thing the German engineers didn't understand and couldn't have understood from inside their own institutional framework. The Americans had been planning for exactly this problem since 1942. Not planning for Cherbourg specifically, planning for the general problem of destroyed ports. Because the Allied planners, particularly the logistical thinkers in the Army Service Forces and the Navy's Civil Engineer Corps, had recognized something fundamental about amphibious operations against a prepared enemy. The enemy will always destroy the ports. Always. It is the rational thing to do. Therefore, the ability to rapidly repair destroyed ports is not a bonus capability. It is a prerequisite for the entire strategic concept. This insight, obvious in retrospect, not at all obvious at the time, drove the creation of a logistics infrastructure that had no German equivalent and, frankly, no precedent in military history. Meet Lieutenant Commander John Paul Morel. He was not at Cherbourg, but he built the machine that was. 51 years old in 1944, civil engineer from Salt Lake City, Utah. Before the war, he was the chief of the Bureau of Yards and Docks for the United States Navy, essentially the chief engineer for all naval shore construction. In March of 1942, Morel proposed the creation of naval construction battalions, units of trained civilian construction workers who would be organized militarily, armed for self-defense, and deployed to build and repair port and base facilities in combat zones. The proposal was approved in 8 days. The first battalion was commissioned in January of 1942. By June of 1944, there were 258 naval construction battalions, the Seabees, with a combined strength of 258,000 men. The majority of them were not 18-year-old recruits, they were experienced tradesmen, welders who had spent 10 years in shipyards, crane operators who had worked the docks of Baltimore and New Orleans, electricians who had wired factories, dredge operators, pile drivers, men who had spent their working lives building exactly the kind of infrastructure the Germans were destroying. The army had a parallel structure, the engineer special brigades, and, critically, the port construction and repair groups, units specifically tasked with restoring damaged port facilities. These were not general-purpose engineer units who happened to do port work. They were specialists, trained on port systems, carrying port-specific equipment, with a doctrine built around rapid assessment and prioritized repair. But the human element was only part of the system. The other part was material. The Army and Navy, working from the assumption that every port they needed would be destroyed, had pre-positioned equipment. Not just tools, industrial-scale salvage and construction equipment, loaded on dedicated vessels, ready to follow the assault forces into any port the combat troops cleared. Floating cranes, pontoon causeways, prefabricated steel pier sections, replacement lock gate components, portable pumping systems. welding equipment in quantities that would have looked like an industrial plant, underwater cutting equipment for the divers who would work in the wrecked harbour basins, dredges, not one or two, but a fleet of them, of various sizes, designed to work in the confined spaces of a damaged harbour. And here is the piece of the system that the German engineers found most inexplicable when they eventually understood it. The Americans had pre-surveyed Cherbourg, not from memory, not from French charts, from their own surveys, conducted covertly, using submarine-based reconnaissance, aerial photography analysed by specialists, and French resistance contacts who provided current information on German modifications to the port. By the time Galat stood at the Quai de France on June 27, 1944, his headquarters already had a damage assessment framework ready to fill in. They knew what was there before the Germans destroyed it. The survey of what the Germans had actually done was a subtraction problem, comparing the pre-demolition baseline against the post-demolition reality, not a discovery problem. That distinction mattered enormously for speed. The Germans had assumed their enemies would arrive at the port, look at the destruction, spend weeks surveying the damage, then weeks more planning the repair sequence, then begin the actual work. This is how port repair had always worked. It is the logical sequence. The Americans had collapsed the first two phases into something that happened before the assault. Stop and think about what that means for the timeline. By the time the fighting was over, the repair plan already existed in outline. The equipment to execute it was already at sea, following the assault convoys. The men to do the work were already organized, trained, and ready. The gap between combat ends and repair begins was measured not in weeks, but in hours. Galat's first repair teams entered the port on June 27th. The last organized German resistance had ended on June 26th. 24 hours. Part 3. 30 days and what it cost. The actual work of reopening Cherbourg is where the story stops being about doctrine and systems and becomes about specific men doing specific things in specific conditions. And the conditions were bad. The harbour was mined. This was not a theoretical problem. On June 28th, one day after repair work began, a Liberty ship, the USS Shea, struck a pressure mine in the outer harbour while attempting to survey the fairway. The explosion killed 3 men and wounded 14 others. Work stopped. Minesweepers came in. They swept for 48 hours and declared the main channel clear. Work resumed. On July 2nd, another vessel, a small salvage tug, detonated a second pressure mine near the inner harbour entrance. No casualties that time, but the tug was badly damaged and had to be withdrawn. The minesweepers came back, they swept again, declared clear again. The problem with pressure mines, and the reason they were so effective as a denial weapon, is that clear is a probabilistic statement, not a guarantee. A pressure mine set to fire on the 15th pressure pulse from a passing vessel will not respond to the first 14 passes of a minesweeper. It will respond to the 15th. You cannot know which pass is the 15th. The only way to clear pressure mines with certainty is time, letting the counters exhaust themselves, or accepting the risk of continued losses. The Americans accepted the risk. Work continued. The dredges went in first because nothing else could happen until the harbour bottom was cleared. The sunken vessels in the outer harbour, 40 of them, remember, had to be either refloated or cut apart in place. Refloating a sunken vessel requires divers to seal the hull breaches, pumps to remove the water, and sufficient buoyancy to bring the hull up without it breaking apart in the process. The Germans had not sunk these ships cleanly. Several had been sunk with explosive charges that left their hulls badly fragmented. Refloating them was not feasible. They had to be cut. Underwater cutting in a harbour that has been blown up is not the same as underwater cutting in clean water. The visibility in Cherbourg harbour in late June and early July of 1944 was, according to the Navy diver reports, between 0 and 18 inches in most locations. The divers worked by touch. They located the hull sections by feel, positioned their cutting equipment by feel, and cut by feel, surfacing periodically to report progress that they could not actually see. The work was slow, dangerous and relentless. Here is where you need a specific name to understand what this actually looks like. Petty Officer First Class Raymond Lussier, 26 years old, from Lowell, Massachusetts. Before the war, he had worked as a commercial diver for a marine salvage company operating out of Boston Harbor, specializing in pier and bridge foundation work. He enlisted in the Navy in September of 1942 and was assigned to a Naval Combat Demolition Unit, then transferred to underwater salvage operations in early 1944. He was part of the diving team assigned to clear the inner harbor lock approaches at Cherbourg. In his official after-action report, a document that survived and is held in the National Archives, Lussier described working in what he called black water for shifts of up to 4 hours. His team's task was to locate and cut apart a sunken barge that the Germans had positioned across the lock entrance, its hull resting on the sill, the concrete threshold of the lock gate opening. To berth a ship in the inner basin, that barge had to come out. To get the barge out, it had to be cut into sections small enough to be lifted by the available floating cranes. To cut it into sections, divers had to get underneath it, in the space between the barge's keel and the lock sill, working in complete darkness in a confined space with underwater cutting torches. Lussier's report is precise about the dimensions. The clearance between the barge keel and the lock sill was approximately 60 centimeters in the deepest section. He was working in a space the width of 2 hands, in zero visibility, with a cutting torch cutting through steel plating of unknown thickness at unknown points of structural integrity, while the barge above him shifted with the tidal current. He wrote in his report, "We worked from the outside in, establishing cut lines by measurement from known reference points on the lock structure. Each diver would make his cut, surface, report the cut length completed, and the next man would go down. We did not rush. Rushing in those conditions would have cost us divers. They did not rush, but they did not stop either. The cranes were the other major obstacle. 7 large cargo cranes toppled into the harbor. Each one had to be dealt with before the key section beneath it could be used. The decision on each crane was the same kind of triage that Galat and his team were running across the entire port. Can this be salvaged and returned to service, or does it need to be cut apart and removed? Of the 7 cranes, 3 were assessed as potentially salvageable. Their main structural members were intact. They had fallen in positions where they could be rigged and lifted without major additional damage, and their mechanical systems, while flooded, were repairable. 4 were total losses. Their falls had been from greater heights, their structures were buckled, and the cost of salvage would exceed the cost of replacement. Those 4 were cut apart by the same underwater teams clearing the harbour basin, their sections lifted out and deposited on the quay for later disposal. The 3 salvageable cranes were rigged by the floating crane teams, massive pontoon-mounted cranes that the Americans had brought specifically for this kind of work, and lifted from the water in the 2nd and 3rd weeks of July. 2 of them were back in service, repaired and operational before the end of the month. The quay wall breaches were handled with a combination of approaches depending on severity. The most serious breaches, where the quay face had collapsed into the harbour, were addressed with temporary steel sheet piling driven into the harbour bottom to create a new faceline, backed with rubble fill. These sections could not bear the load of heavy cargo operations, but they could be used for lighter vessels and for equipment transit. The less severe breaches, where the quay face was cracked but not collapsed, were patched with concrete, rapid-setting concrete, mixed in portable plants that the engineer units had brought with them, poured into formwork that the carpenters erected directly over the damaged sections. This is where the German assessment breaks down most completely. When Henneker's engineers designed the demolition, they calculated repair times based on conventional construction methods. Conventional concrete requires 28 days to cure to full strength. If you have to wait 28 days for your patch to cure before you can load cargo against it, your repair timeline is set by chemistry, not by effort. What they did not account for was that the Americans were not using conventional concrete. They were using rapid setting formulations, some of them achieving working strength in 72 hours rather than 28 days, that had been developed specifically for military construction applications in the preceding 2 years. The chemistry had changed. The Germans were calculating against a materials baseline that was already obsolete. The electrical systems were replaced rather than repaired. The Germans had destroyed the generators at the source. The Americans brought their own generators, large trailer-mounted units, and ran temporary power distribution from them to the cranes, the lighting, and the pumping systems. They did not try to restore the German-installed electrical infrastructure. They bypassed it entirely. The fresh water system was the same story. Rather than repairing the destroyed pumping stations, the Americans established new water supply points using portable filtration and pumping equipment, drawing from the city's water system at points upstream of the contamination and distributing to port facilities through temporary lines. And here is the figure that sits at the center of this entire story. 12 days after Galat entered the port on July 9, 1944, the first Liberty ship berthed at a repaired quay in Cherbourg and began discharging cargo. Not all of the port was operational, not even most of it, but one berth at one quay section with one crane operational was receiving cargo. The port was alive. The German estimate had been 90 days minimum, 180 days more likely, 12 days. We have reached the midpoint of this investigation, and the place where it needs to be said plainly. The men who did this work, the divers, the crane operators, the concrete men, the electricians, the dredge crews, were not performing miracles. They were performing the work they had been trained to perform, with the equipment that had been prepared for them, according to a plan that had been written before they arrived. The miracle, if there is one, belongs to the system, but the men still had to do the work. In mined water, in zero visibility, in a harbour that was still occasionally exploding around them. If this investigation is giving you a clearer picture of what the logistics of the war actually looked like, not the version that survived in the headline numbers, but the version that the men wrote in after-action reports when they thought only their commanding officers would read them, hit the like button. It keeps this kind of history visible a little longer, and that matters. Part 4. The Forensic Verdict. That is the forensic verdict of this investigation. The Germans failed to deny Cherbourg to the Allies, not because their demolition was inadequate. It was not inadequate. By any pre-existing standard for port demolition, Henneker's work was comprehensive, professional, and well executed. Hitler was right to give him the Knight's Cross, if your metric is thoroughness. The demolition was thorough. The Germans failed because they were calculating against the wrong baseline. Their estimates, 90 days, 180 days, were based on what it would take for a conventional engineering organization to repair that damage using conventional methods and conventional materials. They were correct calculations. If you gave those numbers to a French port authority in peacetime, or to a British harbour board in 1939, those estimates would probably have been accurate. The problem is that by June of 1944, the Americans were not a conventional engineering organization. They were something that had not existed before, an industrialized military logistics machine specifically optimized for exactly this problem. Consider what had to be simultaneously true for the American response to be possible. The specialized personnel, the Seabees, the port construction and repair units had to exist and be trained. The specialized equipment, the floating cranes, the rapid setting concrete, the portable generators, the dredge fleet had to have been manufactured, loaded, and positioned. The pre-operational survey had to have been conducted, and the data had to be in the hands of the right people. The doctrine, the specific sequence of priorities, the triage framework, the decision rules for what to salvage versus cut had to have been developed, written down, and trained against. The command structure to coordinate all of this had to be in place. And all of it had to arrive at Cherbourg within hours of the combat ending. Every single one of those things was true, not by accident, by 3 years of deliberate institutional preparation. The specific numbers that resulted from this preparation are worth holding in sequence. On July 9th, 12 days after repair began, first cargo discharge. By July 25th, 38 days after repair began, Cherbourg was handling approximately 150,000 tons of supplies per month. By September of 1944, the port was handling over 400,000 tons per month, exceeding its pre-war commercial capacity. The Germans had estimated the port would be unable to handle significant tonnage for 90 to 180 days. In fact, it was handling significant tonnage in 12 days and exceeding its pre-war peak within 90 days. The gap between the German estimate and the American reality is not a rounding error. It is not the result of exceptional individual effort or inspired improvisation. It is the quantified output of a system that the Germans did not know existed. There is a secondary irony buried in this story that deserves to be stated directly. The German demolition plan was itself a product of sophisticated engineering thinking. Hennecker and his staff had correctly identified every critical vulnerability in the port, the cranes, the quay walls, the lock gates, the electrical systems, the harbour obstructions, and had attacked them in a rational priority sequence. They knew their business. The tragedy, from their perspective, is that knowing your business is only half the problem. You also have to know your enemy's business. And the German engineers had no framework for understanding what the American logistics system had become, because nothing like it had ever existed before. When the captured German demolition reports were analysed by American engineers after the war, the assessments were respectful, the work was good, the calculations were sound. The problem was the assumptions embedded in those calculations, assumptions about what normal port repair capacity looked like, that had been rendered obsolete by an industrial mobilization the Germans had not tracked closely enough. Walter Hennecker was held as a prisoner of war until 1947. He returned to West Germany, worked briefly in the private maritime sector, and died in Hamburg in 1980. He was 77 years old. In the post-war years, he gave several interviews in which he discussed the Cherbourg demolition. He never expressed regret about the technical work. He expressed, with what appears to be genuine puzzlement, continued difficulty understanding how the Americans had moved as quickly as they did. In one interview, he said that the speed of the American repair suggested either a very large organization or a very good plan. He paused and then added, "Probably both." He was right. It was both. And the fact that he arrived at that conclusion only in retrospect, only after seeing the results, is the most precise possible illustration of the German intelligence failure at the operational level. Doswell Gullett, 43 years old in 1944, Georgia-born civil engineer. He returned to the United States after the war, continued working with the Army Corps of Engineers, and retired in the 1960s. He died in 1978. His after-action report on Cherbourg, a document of approximately 40 pages, written in the flat, precise language of a professional engineer, is held in the National Archives in College Park, Maryland. It contains no triumphalism, no celebration. It reads as what it is, a technical record of a job that needed to be done and was done. The closest thing to emotion in the entire document is a note in the final paragraph, where Gullett writes that the work demonstrated capabilities of American construction forces which I believe were not previously understood, even within our own service. Even within our own service. Think about what that means. The machine was so new, so rapidly assembled, so unprecedented in scale, that even the American officers running it did not fully understand what it could do until it did it. Raymond Lucier, the diver from Lowell, Massachusetts, he survived the war. He went back to commercial diving after his discharge, working out of Boston for another 2 decades. He died in 1989. His after-action report, the one with the 60-centimeter clearance, the zero visibility, the instruction to not rush, was filed and forgotten in the archives for decades. It is not a famous document. It was never meant to be. It was a petty officer telling his chain of command what his team had done and how they had done it, in the expectation that only a few people would ever read it. He was right about that too. Now return to where this started, June 1944. Colonel Doswell Galat, standing at the Quai de France, the black water, the toppled cranes, the collapsed quay faces, the mine-seeded harbour. The note in his professional notebook, the most comprehensively destroyed port facility I had ever seen or expect to see in my professional lifetime. He was not wrong about the destruction. He was right. It was comprehensive. What he understood, standing there, that Henniker did not understand when he signed off on the demolition orders, was that comprehensiveness is only a meaningful concept relative to the capacity of the force trying to overcome it. The Germans had built their demolition plan around a capacity estimate that was 3 years out of date. The Americans had spent those 3 years building something new. Galat opened his notebook. He began to write. And 12 days later, a ship came in. That is the verdict. Not a miracle, not improvisation, not exceptional individual heroism, though there was plenty of that in the black water of the inner harbour. A system, built deliberately, funded deliberately, staffed deliberately, aimed at exactly this problem. The Germans were excellent engineers. They destroyed the port exactly as well as they intended to. And it wasn't enough. Not because of any failure on their part, but because the Americans had been quietly building the answer to their question for 3 years before the question was even asked. If this investigation gave you something, a sharper picture of what the logistics war actually looked like, and why the gap between German estimates and American results was not a matter of luck, hit the like button. Subscribe if you want the next chapter. And remember this, the most dangerous opponent is not the one who fights better than you expect. It is the one who has been preparing, quietly and systematically, for the specific problem you were certain would stop them. Galat stood at the edge of the quay. He opened his notebook. He began to write.